Hey everyone, I am Priyanshagwa and welcome back to my YouTube channel. Today we will be solving today's Leetcode daily challenge, which is find eventual safe states. Okay, so let's see what is this question and how we can solve it. So in this question, we have been given with a directed graph of n nodes with each node levered from 0 to n minus 1. Directed graph means these arrows. There is an edge from this to this node. Okay. And the graph is represented by a zero indexed 2D integer array graph where graph I is an integer array of nodes adjacent to node I, meaning there is an edge from node I to each node in graph I. Okay, so what they are saying is that let's suppose this is 0, 1, 2, 3, 4, 5, 6, right? So 0 has an edge with 1 and 2 and 1 has an edge with 2 and 3. 1 has an edge with 2 and 3. So they are saying this. In this way, we have been given with a graph, right? Okay. And a node is a terminal node if there is no outgoing edges. Means if we have been given with a node, then this node is a terminal node only if there is no outgoing edge. It can have any number of incoming edges, but there should be no outgoing edge. Okay. And a node is a safe node if every possible path starting from that node leads to a terminal node or another safe node. Okay. So let's suppose this is a node. How we can get to know that whether this is a safe node or not? This will be a safe node if it leads to a path to a safe node or a terminal node, right? Okay. So we need to return an array containing of all safe nodes of the graph. And the answer should be strawberry assembly. Okay, let's see. So what we need to do is we need to find all the safe nodes. And the safe node is the which node? Which leads to a path to a safe node or terminal. Okay, so let's first create this graph and then we'll see what we can do to solve this question. So 0 has edge with 1 and 2, right? And 1 has edge with 2 and 3, okay? And 2 has edge with 5, okay? And 3 has edge with 0, okay? 3 has edge with 0. 4 has edge with 5, okay? And 5 don't have any outgoing edge, and there is also a 6 node dangling here, okay? So what we can see here? From my naked eyes, I can see that there is no outgoing edge from 5 and 6. So my answer 5 and 6 should be my answer because a terminal node is a node which has no outgoing edge and a safe node is a node which leads to a terminal node. So terminal nodes will also be safe nodes. Okay. And I can see 2 leads to a terminal node. So 2 will also be a safe node. 4 leads to a terminal node, then 4 will also be a safe node. So in this graph from my observation, these all will be safe nodes, right? Okay. But see here, 3 is dependent on 0, 0 is dependent on 1 is dependent on 3. So these are not the part of our safe nodes. So what you can observe from here is that 0 has an edge with 1, 1 has an edge with 3, and 3 has an edge with 0. Means if there is a cycle, then those nodes cannot be a part of safe node. The nodes which are participating in a cycle cannot be a safe node. So now what our question reduces to, we need to find the cycle in our graph, right? Or we can say that we need to find the nodes which are not the part of a cycle in a graph, right? Okay. So how we can find the cycle in a graph? Okay, so let's see. So we can also find the cycle in a graph with the help of topological sorting, right? Okay, so let's see if we can apply the topological sort directly here or not. Okay, so in topological sort, we start pushing the nodes which have in degree 0. So in this, we will start with 4 and 6, right? Okay, then 4 and 6 will get eliminated. Okay, and then see, here we are stuck because 5 is dependent on 2, 2 is dependent on 0 and 1. So here we are getting stuck because we are not able to get out all the safe nodes. Okay, so let's try reversing of these edges. That's one try. Then we take why we are reversing. Okay, then 0, and this will get reversed to this 1, and this will also get reversed, and this will also get reversed to 2, 5, 4, and 6. Why we are reversing it? Because if we are not reversing it, then we were not able to get out all the safe nodes. And if we reverse it, then there is no impact on the nodes which contains a cycle because we just reverse the nodes, but cycle is still intact. So there is no impact on the cyclic part. Okay, but there is impact on the rest of the part because in this way we will able to get out all of the safe nodes. See how. In this, 5 and 6 was our terminal nodes as we have observed. And now if we have reversed their edges, then their in degree has become 0. So we can push them in our queue with from in the topological sort. See, the terminal edges are those which have not any outgoing edges. And if we have reversed the edges, so what are terminal nodes? Which don't have any incoming edge, right? So if we have pushed these two nodes in the queue, now these are eliminated. 5 is also eliminated. Now we will push 4 in the queue, right? If we pop out 5 and 6, okay. So if we push 4 in the queue, now 4 is also eliminated, right? Now we can also push 2 because 5 is eliminated, so its in degree has also become 0. Okay, so these two edges has also been eliminated. Now these nodes are stuck in a cycle and they never get pushed in our queue. So if we have reversed the edges in our graph, then we are able to get all these safe nodes in our from our graph, right? Okay, so I hope you get this intuition and this dry run. So let's code it so that you will get a better idea of it. Okay, let's first store the total number of nodes. Okay, and then we will need to create a adjacency graph adjoint of size n, right? And we will also need to create a in degree vector of size n initially with 0. Now we will iterate in our graph I is less than n, I plus plus, for in j is equals to 0, j is less than graph I dot size and j plus plus, and we will, as we are reversing the edges, so what we will do, adjacency of graph ij dot push back I, right? In this way we are able to reverse it and we will increment the in degree of I, right? Okay, now we will create a queue and push all the nodes which have in degree as 0. If in degree of I equals to 0, then we will simply push them in our queue. Right, now we will iterate on our queue. While queue not empty, and we will also create a Boolean vector for storing the safe nodes. Safe nodes n comma started initialized with 4. And as this its in degree is 0, it means it's a safe node, right? So safe node of I equals to 1. Okay, so now we will start popping out from our q dot pop, and we will iterate on its neighbors, adjacency of node, and if we will decrements its in degree, right? And if its in degree is 0, if its in degree is 0, it means it's a safe node or a terminal node. It's a safe node because we have already stored the terminal nodes in this loop. So what we will do? We will push it in our queue, and we will also made it true. Safe node of neighbor equals to 1. Right? Now as we need to return a sorted vector, so integer vector. So we will create a final result vector of uh, and then we will iterate on these safe nodes. If is safe of I is true, then we will simply push that in our result vector and finally return our result. So instead of creating this Boolean vector, you could also have created this directly, but as we need to return an answer in the sorted order, ascending order, so eventually we will need to sort it, and then it can take up to a complexity of n log n. So that's why I have created a Boolean vector so that it will not take up n log n complexity, and we are able to solve it in n only, this loop into n complexity only. Okay, so let's try run this. Okay, it's safe now. It is safe nodes. Safe nodes. Yeah, yeah, it's working fine. Let's try submitting it. Yeah, it's working fine. Now let's talk about its time and space complexity. So as we are iterating on all the nodes and its edges, so its time complexity will be big of n plus m, considering n is the number of nodes and m is the number of edges. And the space complexity will also be n plus m, as we have created an adjacency list for storing all the nodes and the edges, right? So this will be its time and space complexities. I hope you get this question and solution. If you still have any doubts, and you can surely post in the comment section, I will try to answer them. Till then, bye guys, see you in the next video.